Hello again, this is Gary, and we're going to continue with our digesting drawings. This is part two of the AC Elementary 3-line. I wanted you to look at this because there are some things on this drawing that is different than the previous drawing. And what you'll notice here is this CT circuit leaving breaker T362 on the transformer side. It goes through two sets of relays. So you notice we'll just pick a phase. We'll pick phase 3. We'll come down. Block DK3, shorting block, terminal board TB22 148, C3 comes down to panel 109. The first relay hits. It's an SEL 451. That's the name of the relay. The second relay, it goes back to the terminal block. From there, it goes from panel 109 to panel 113, panel terminal block 87. Then it goes to this SEL 47B, which is an SEL bus differential relay. And that's the name of the relay. And then it comes out here and it goes to another device. We have to look at this drawing. But one thing I wanted you to pay attention here is this single point ground. You don't have a single point ground for every relay. You have a single point ground for every CT circuit. So this particular CT circuit, these three, A, B, C, and return neutral, has one single point ground. Sometimes you'll see two, and that's a red flag that one of them has to go away. You can't have two single point grounds on one set of CT circuits. This is an important thing you have to pay attention to. Okay, that's what I wanted to show you on this particular drawing. So we're just going to go on to the next drawing. And now on the AC elementaries, it also shows PT circuits, or CCVT. So from the CCVT, it goes from the actual CCVT itself. There's one per phase. There's A, B, and C, or 1, 2, and 3. It goes to a secondary junction box, which is mounted at the base of the CCVT, or the base of the structure. All three CCVTs are wired into this device, into this box. The dash means it's located in another location, and the square with the X is also clear that it's located in another location. So what I want you to pay attention to is utilities have standards for PT circuits or CCVT circuits. In this particular circuit, the standard is you cannot have a test finger for the neutral. It has to be a hard jumper connection. Here they use a piece of copper, and they call it a little bus bar. Why is that there? Because when the operator comes out to the J box for the CCVT, he can isolate A, B, and C phase. But if you were to accidentally open this with, which is the neutral, and you have these phases closed in, and the CCVTs are energized, the device that's reading this voltage, and this one is SCL 351 or 451, this is a 451, 451, these relays will lose their reference and the voltage will float. So that is why they eliminated the knife blade here and put the slug in here. So when you're verifying these circuits, when I look at this on the PT circuit, CCVT circuit, I'm paying attention to this slug to make sure it's there and make sure there's a single point ground. You notice this set of CCVTs only has one single point ground. It's right here in one slug. This right here is a 3-gang breaker, and it's rated for 30 amps. So that's your protection. So I just follow this along. This is one phase. It comes down We're going to call this A phase. It goes into the test finger, into this relay 451, into the polarity side for the A phase coil for PT, voltage sensing. There's B phase, goes to BBY, C phase. I'm just looking at to make sure it all makes sense. And then the secondary side of the relay, it's all getting together. It comes back through a set of test fingers and comes back to the neutral. So that all makes sense. I have A, B, C in neutral, leaving the CCVTs, and A, B, C in neutral, going into and out of the relay. And this voltage continues. The next parallel path is this relay. And then the next parallel path is this relay. You notice this in panel 110, and this is in panel 109. So that is a PT circuit or a CCVT circuit. Over here, we have another CCVT circuit. Okay, this is called Y winding A protection, and this is X winding B protection. So if you notice here, they only use one of the phases. It's still set up like this, but they're only using one of the phases. That's the neutral, and that's the potential coming out. It's 120 volts, so the potential from here to here is 120 volts, phase neutral, and it's going to the transformer bank 3 low tap changer control. All right. And this is just a description of the voltage input distribution from bus 8, bank 3, bank 2, and bus 4, and how they feed into the relays. For example, this 451 relay is getting VY from bus 8 and VZ from bank 3. And bus 4 comes into this relay, VY, and then VZ from this relay and VZ from this relay is coming off a bank 2 transformer. So it just gives you a high-level view of how the voltage is fed into these devices. You can also see this in the Power 1 line. Okay, and also pay attention to the notes. See this note 1, 120 volt signal required for tap changer control. That's the tap changer controller. So we go up here. Here's note 1, to transformer bank 3 low tap changer controller. That's the 120 volts coming off of these set of PTs. All right, that's it. Have a wonderful day, guys.